Hello, Math 30-1 students. I believe we are on lesson 5 today, so let's just take a peek at what we've learned. We have now studied the living bejeebers, that's a technical term, out of this equation right here, which is on your formula sheet, all right? It is your job to know every single one of these letters. A, vertical stretch, makes you tall, makes you short, influences Y. B, horizontal stretch, makes you wide, makes you narrow, influences X. Remember, B is not the horizontal stretch. If B's big, you actually get narrow. If B's little, you actually get wide. All right? So influencing Y, influencing X. If this is negative, this is a reflection in the x-axis. Your x-intercepts are invariant. If B is negative, this is a reflection in the y-axis. Your y-intercept is going to be invariant. All right? Right here, H. This is a horizontal movement. This is going to move us left, right. Remember, it's backwards. X plus 11, left. X minus 12, right. This is influencing X, by the way. K, influencing Y, is a vertical translation, vertical movement. It makes sense. Plus 13, up. Minus 14, down. All right, today I think we're going to page 16. We'll get there in a second. But we are going to talk about this, which is the inverse of a function. All right? So we can reflect over the x-axis, make A negative. We can reflect over the y-axis, make B negative. Here we are going to reflect over a different line, and I'll get to that. Excuse me. All right. We are on page 16, I believe. And here, no, pardon me, not 16. What page are we on? 20? 20! We're on page 20 today. All right. Lesson 5. Inverse of a relation. All we are going to do is students will be able to sketch and graph the inverse of a relation, determine if the relation of its inverse are functions, and determine the equation of an inverse. This is not terribly difficult. All right. Here's the good news. If our A value is negative, we reflect over the line y is equal to 0, otherwise known as the x-axis. If the B value is negative, we reflect over the line x equals 0, otherwise known as the y-axis. Well, an inverse actually reflects over the line y is equal to x. So if you ever want to do an inverse, all you have to do is lay down a nice 45-degree line, y is equal to x, and then swap your x's and your y's. All an inverse is swap your y's and your x's. And I'll show you what that means, all right? So, for example, if I had 2, 3 as my original point, the inverse would become 3, 2. I literally swapped the y and the x. If you have an equation, y is equal to 4x, the inverse will be x is equal to 4y. Swap your y and your x. Everything about an inverse swaps x and y. And we're going to see that with domain and range in just a couple seconds here. We're going to see that with x and y intercepts. All right, so if given a graph or a set of ordered pairs, reverse the x and y values. That's literally what I just said, all right? Why? When you reflect a point or a graph in the line y is equal to x, the coordinates are reversed. So we slide down here, and I will show you how easy this is. And I'm using my mouse, but it's not all that great. So let's take a peek. This is at -3, -3. Well, I want you to swap -3 and -3, and I think you'll agree with me that they become -3, -3. Haha, invariant. Right here is 0, -6. Well, won't that become -6, 0? So I can connect these two dots right there. This point right here, it doesn't look like I have a very nice point, but it's about, let's say, 2.8, 0. Well, that'll become 0, 2.8. Right up here becomes 5, 5. I do believe that that's going to reflect to 5, 5. Oh, hello, another invariant point. Do you see this point here, who is 10, 5? Won't that become 5, 10? So all I'm doing is taking every point, finding it on the grid, and swapping. And so now I can connect here, I can connect there, and I can connect there. And there she is. Now, let's see if I can do something here. Let's make this purple. I'm supposed to reflect over the line y is equal to x. Okay, you don't have to draw this. I'm just having some fun. But y is equal to x, I think, looks something like this. Again, not my greatest graphing ever, but here's the line y is equal to x. There she is. And I'm just going through every single point, just like that. Notice how black, oops, sorry, I didn't mean to put that point there. Notice how black flipped over purple and became red. Black flipped over purple and became red. So when you do an inverse of a graph, you could always draw y is equal to x, my so-called purple line there, and then swap your y's and your x's. All right? Now, let's have some fun. I'm just going to get rid of that purple because it's kind of in my way. Let's talk the domain of the original. Are we in agreement that the domain of the original is from -3? I'm assuming this goes on forever. It's going up to 10. So this thing here, and I'm being bad because I'm trying to use my mouse. I got to fix that coloring. I don't like that. X is greater than or equal to -3. All right? I apologize. I should really be writing that in either set notation. X is a set such that x is greater than or equal to -3, comma, x is a member of the reals. I just don't have the room to write that. Range. Is it just me, or are we going from -6 all the way up to 5? I believe that the range of this function is from -6 all the way up to 5. So I'm going to say that I'm -6, and then less than or equal to y less than or equal to 5. Hopefully I got that right. -6 all the way up to 5. All right? Now, what's the x-intercept? Looks like the x-intercept, I think I said, was about 2.8. So I'll make this 2.8, 2.8, comma, 0, and put a nice little bracket around that. Y-intercept certainly appears to be -6. So I'm looking at 0, -6. All right. So, no problem. Can I make my, let's see, can I change this so it's not so thick? Oh, right here, right here. Let's make, there we go. Make this a little thinner. Okay, good. All right. Now, the domain of the inverse. Anyone noticing that red goes from -6 to 5 on the inverse? So I'll do this in, I'm looking at -6 up to x, who's going up to 5. Boom. Let's talk the range of red. Looks like it's -3 going all the way up. So I believe that y is going to be greater than or equal to -3. All right, what am I looking at an x-intercept? I believe that was -6. Oh, my x-intercept is -6, comma, 0. And what do I have for a y-intercept? Can't tell you exactly, except for the fact that I know that this is 2.8, so I'm going to say that this y-intercept is 2.8. 0, comma, 2.8. Now, I want you to notice something. Notice all the x's and y's switched. Little blue. Notice how this domain became inverse's range. This range became this inverse's domain. X-intercept became the inverse's y-intercept. Y-intercept became the inverse's X-intercept. Everything relating to X and Y switch. Alrighty, invariant points. Well, where are the invariant points? I think I got one right here. I don't think it moved at -3, -3. So lo and behold, -3, -3. And what's the other one up here? Oh, I think there was one right there who turned out to be 5, 5. Here's what I can tell you about the invariant points on an inverse. They're always going to be where X and Y are equal. The answer is always going to be 1, 1, -12, -12, 17, 17, pi, pi. Because you're flipping over the line Y is equal to X, you're always going to have where Y and X are the same number. So the key here is to notice that everything in an inverse swaps. All right, determine the x-intercept of the inverse of this graph. Now, there are 2 ways to do this. I will teach you how to find the inverse of that equation. Or you can be cheap and easy and say, well, wait a second. The x-intercept of the inverse will be the y-intercept of the original. Will it not? I will show you on the next page how to find the inverse of this equation. But you can actually save yourself some time and say, I don't need to go and manipulate this equation. If I want the x-intercept of the inverse, it's the y-intercept of this current equation. Well, what's the definition of a y-intercept? I do believe the definition of a y-intercept is where x is equal to 0. So lo and behold, this all disappears. Anyone else confirming that it's going to be -7? So this guy's y-intercept is 0, -7. That is the y-intercept of the original. I don't want this. The x-intercept of the inverse is going to be -7, 0. So what you have to realize here is the x-intercept of the inverse is the original's y-intercept. The y-intercept of the inverse is the original's x-intercept. That's what this question is trying to make you realize. All right, on to page 21. So, here it is. Now I teach you how to find the equation of an inverse. All right, determine the inverse equations of the following. Well, hopefully you realize that I have been saying over and over again that I need you to realize that when you do this, y and x swap. Now you might say to me, but there's no y here. No problem. Go back to grade 10. Isn't this equation actually going to be y is equal to -2/3 x plus 5? Oh, sorry, that's an x. That's ugly, Mr. Chandler. That's embarrassing. Let's fix it. Oh, I lost it all. Oh, well. Y is equal to -2/3 x plus 5. You know, I'm going to try something funny here. Okay, so there's the original. Now what we are going to do is we are going to figure out what the inverse is. I'm going to pause this and I'm going to change things here up and I'm going to see if I can come back. Give me a second. Okay, I'm back. I just took a couple minutes and I typed this up so that instead of me like royally messing it up with trying to use my mouse at home, I can actually just walk you through this. Okay, so here's what's going on. We are attempting to find the inverse of this equation. And I have shown you, taught you, told you that you simply swap the x and the y. Now, first thing is you're going to say to me, but we don't have a y in this. But we go back to grade 10, and f of x is just another way of writing y equals. So my first line here is simply me saying, hey, instead of f of x, write it as y. I didn't change anything over here, right? It's exactly what it was. All right, now we make the swap. This y becomes an x. This x becomes a y. You'll notice the numbers haven't moved. I literally swapped the x and the y in the second step. After this, it is a grade 10 question, re-isolate the y. In other words, get this adding 5 to the other side of the equation. Get this dividing 3 to the other side of the equation. Get this multiplying 2 to the other side of the equation. And that's all I'm about to do step by step. To get rid of an adding 5 is a subtracting 5. So all I did here was move this 5 right there, and I moved her over to the other side. Opposite symbols. Addition becomes subtraction. How do you get rid of a dividing 3? Yeah, you multiply by 3. So I just multiplied this entire left-hand side by 3. 3 times x, 3x. 3 times negative 5, negative 50. That's how I got rid of a dividing 3. How do I get rid of a multiplying 2? I divide by negative 2. Now, I must admit, technically, this is correct. I'm not saying it's wrong, but we just don't typically write a negative in the denominator. So all I did was I distributed that negative 2 into both of those terms in the numerator. 3 over negative 2, negative 3 halves x. Negative 15 divided by negative 2, positive 15 over 2. You want to write 7.5? Go for it. Okay, so if this was correct, this is even more correct. Now, when you write an inverse, and if we go back to the very first page, what was the very first page? All right, actually, no, maybe we had it on the, yeah, let's go back to the page 1. What I want you to show you is an inverse can be written in this form, where it's f of negative 1 of x, or the more traditional, yeah, I swap x and y. The diploma will use both, so I'm going to use both throughout today's lesson. But what I'm trying to show you is, yes, this is the answer. Because it's an inverse, I write it in the f of negative 1 of x. So this, my students, is what the diploma would have down on its multiple choice, or if it was looking for a long answer written response, that's what they're wanting. Okay, so let's come back up to here. We've got a nice grade 11 quadratic function. Well, my first step was I simply replaced the f of x with y, because now I can do the swap. Y becomes x, x becomes y. All right? Now you know the algebra. How do you get rid of a subtracting 9? You add 9. How do you get rid? Oh my goodness, look at my bad typing down here. I'm going to have to fix that. Oh, how embarrassing. How do you get rid of a multiplying 3? You divide 3. Now, this is good so far. I have made a typing boo-boo. This should actually say divide 3. So terribly sorry about that. Divide 3. And this should say divide 3. Bad typing, Mr. Chandler. Now, if you want to write this as 1/3 x plus 3, go for it. You want to leave it as x plus 9 over 3, go for it. It's the same thing. Now, how do you get rid of a square? Well, the opposite is a square root. As I mentioned over here, great, we have an inverse. So instead of writing equals y, I'm writing it as f of negative 1 of x. Now, I want you to realize something. This is partially correct. You're going to say to me, Mr. Chandler, what the heck is this right here? This plus minus thing? Ah! Oh no, sorry about that. What the heck is this plus minus thing? Well, I'm going to show you, okay? And here's what you need to realize. If you type in the square root of 9 on your calculator will only give you positive 3 as an answer. So, if you were to graph this, and go ahead and graph this for all I care, what you're going to find is it's only going to give you the top half of the equation. You're going to see this. And there should be a bottom half of the equation. All right? To get the bottom half, you must write plus and minus. So when doing an inverse and you get rid of a square, you must have a plus minus in front of your radical sign. That will then allow the calculator to correctly graph the inverse, who looks like that. So what I need you to realize here is we changed it from f of x to y. We swapped the x and the y's. Then we did some grade 10 algebra. Got rid of a subtracting 9 with addition. Got rid of a multiplying 3 with division. Got rid of a square with a square root. When you use a square root, you must put the plus minus. All right, last question here. Same thing, no problem. So look at this. We got f of x. I simply wrote it as y equals. So step number 1 was replace the f of x with y. Now it's grade 10, we swap. Y becomes x becomes y. And now it's grade 10, time to do our algebra. The -1 came over and became addition. How do you get rid of a square? You square root. Notice I just wrote the square root, but then I realized, oh yeah, plus minus. How do you get rid of an adding 3? You subtract 3. So that way, the plus minus of the radical, and then it's always a subtracting 3. Because I'm writing inverse, I write f of -1 of x. So, to review, on these 3 questions, if it's given as f of x, write it as y equals. Swap the x and the y, re-isolate your x. Your y. So terribly sorry. Alrighty, grade 10. With any luck, you remember that grade 10 taught the vertical line test. The vertical line test simply said, hey, if a vertical line touches your graph once, then yes, you are a function. All right? So, watch this. I'm just going to draw a vertical. Oh, no, it's kind of vertical. Close enough. Now, this first guy, the vertical line only ever touches once. Yes, number 1 is a function. So I'm going to put a little check mark right there. Number 2, vertical line hitting twice. Number 2 is not a function. So I could not write this as f of x. Impossible. Number 3, well, that's just a nice little grade 10 line. Yep, loving it. I got no issues here. So number 3, yes, a function. Okay, well, we'll just put a little check mark. Bada bing, bada boom. Talk to me about number 4. Now, sure, I like this. Look at this vertical line, only ever touching once. Right? Notice, no x produces 2 y's. That's basically the other definition of a function. Right here, like you look at this, right here, I'll just do this in maybe in green or something. I'll do it in blue. When x is 2, it's producing 2 separate y's. That's a bad thing. So, this guy, absolutely, function. Number 5, I got issues. Look at number 5. Sure, this is okay over here. I'm fine here, but I blow up right in here. So I got to think that number 5, n'est pas de function, for all of my French students. All right, so grade 10, something is a function if it passes the vertical line test, where a vertical line touches the graph only once. Okay, fine, next page. What do we got here? Oh, good. So I've been discussing this. If the inverse satisfies the vertical line test, then we can use this notation. All right? If the inverse does not satisfy the vertical line test, then we have to use this notation. All right? Now, I'll teach you how to figure this out in a second. But the diploma will use both of these notations simultaneously if they can, and you need to recognize both of them. All right. Now, here's what's cool. The exact same 5 questions, but this time I don't want to know if these guys are functions. I want to know if their inverse would be a function. Now, you could go and graph the inverse if you wanted to. But then you'd have to spend some time graphing the inverse and doing the vertical line test. But go back to the beginning of my lesson. Haven't I said that everything in an inverse swaps? So a vertical up-down line swaps on an inverse and becomes a horizontal line test. And that's what it says up here. We can do the horizontal line test, which means if a horizontal line touches the original twice or more, then the inverse is not a function. I admit, number one is a function. He passes the vertical line test. But he fails the horizontal line test, which means his inverse is not a function. Take a peek at this guy. Whoops, that's not what I wanted to do. Come on, Mr. Chandler, grab that graph here. That's better. Uh-oh. Horizontal line test, failure, which means the inverse is not a function. Agreed? So this guy is not a function, nor is his inverse a function. All right. Now, number 3, the original is a function, and his inverse is a function. Aha! The inverse would be. Number 4. Number 4 looks good in the middle, but disaster down here, touching twice. Epic disaster right there, touching an infinite number of times. I'm going to have to say that number 4's inverse, not a function. Lastly, number 5, the original was not a function, but look at this. His inverse would be a function. Oh, isn't that cool? So lo and behold, while this guy is not a function to begin with, his inverse would be a function. So it's simply called the horizontal line test. A horizontal line test is going to tell you if the inverse is a function. Now, this is kind of like genetics. Do you agree it's possible for a father to have some sort of, and I'm no biologist, never took biology in high school, but maybe I have this, abnormality in my chromosomes, but I don't show any of the, the symptoms, the issues. But then if my wife also carried the same sort of abnormality, wouldn't that then mean that our children would definitely have it? This is the same sort of thing here. So the horizontal line test is just telling you not about the original, but about the inverse. All right, so how far are we going today? I can't remember. I got page 23. I just got page 23 left. Outstanding. All righty. Consider the function x squared minus 1. All right. I am hoping that grade 11 quadratics, you are visualizing this as a quadratic, and you have a certain shape in your head. So I'm thinking, I got a nice X-intercept. Something, I'm going to do this in blue. I got a nice, Y-intercept at -1. Now, you could totally do a table of values here. I got no problem with this. Hey, put an x is 1 in. 1 squared is 1, minus 1 is 0. Bang. Put a 2 in. 2 squared is 4, minus 1 is 3. 2 comma 3. Put a 3 in. 3 squared is 9, minus 1 is 8. Oh, well, that was nice. I can now see on the right side, this thing looks something like that. I apologize. Hopefully you'll do a better job of graphing. Alrighty, well, putting a -1 in, -1 squared is 1, minus 1 is 0. Oh, yeah, there's a nice axis of symmetry going on here. -2 squared is 4, minus 1 is 3. Yeah, look at that, totally symmetrical. Putting a -3 in, -3 squared is 9, minus 1 is 8. Yeah, she's looking right there. And this quadratic looks something like this. I apologize, I should have hit that dot, but you get my point. You got a quadratic. I made it just by making a quick table of values in my head. Now, is that a function? The answer is yes. It passes the vertical line test. Is the inverse a function? And the answer is no. How come? I'm just going to make a quick line here. It fails the horizontal line test. Because it fails the horizontal line test, its inverse is not a function. So, will the inverse be a function? I have to say no. Now, it says determine the equation of the inverse. Okay, well, hopefully I can do this fairly easily. I know that this is supposed to be y is equal to x squared minus 1, so I'm just going to cut to the chase. X is equal to y squared minus 1. There she is. Now, move the 1 over. I got myself a nice little x plus 1 is supposed to equal y squared. And if you don't mind, I'm just going to take the square root and realize that I get that. So all I did, because I did a couple steps in my head, I made this y equal to x squared minus 1, swapped the y for x, swapped the x for y. Great. What did I do next? I moved the 1 over. She became addition. How did I get rid of a square? I square rooted. But some of you are screaming. I can already hear it. Because I square rooted, you need the plus minus. That is the equation that I'm looking for right there. Now, can I change this to f negative 1 of x? And the answer is no, because I know it's actually not a function. So I got to leave it like that. Now, graph the inverse on the same set of coordinate axes. Not a problem. All I'm going to do, and I'll do this thing in green, I'm going to take every single point and swap it. 0, negative 1 will become negative 1, comma 0. 1, 0 will become 0, 1. 2, 3 will become 3, 2. 3, 8 will become 8, 3. So I now have this right here. And this green is what you will get on your calculator if you don't have a plus minus on your calculator. To graph this on your calculator, you have to do it twice. You've got to type in y equals square root x plus 1. Then in y2, you've got to graph y equals negative square root x plus 1. All right. Well, let's take a pick at this one. I've already done this point. This was negative 1, 0, who will become 0, negative 1. This is negative 2, 3, who will become 3, negative 2. This is negative 3, 8, who will become 8, negative 3. And then I will get this right there. Bada bing, bada boom. Alrighty. So that is my graph of the inverse. I determine the equation, and if I wanted to put this into the calculator, I'd go to y equals and graph in y1 root x plus 1, and then in y2, I would go negative root x plus 1. y1 gives me the top half, y2 gives me the bottom half. Graph the inverse on the same set of coordinate axes, done. Now, the diploma loves question D. Describe how the domain could be restricted so that the inverse is a function. Now, I'm just going to get rid of this green, only so I can, show you guys some stuff. So it's there, don't worry. I'm just moving it so that we can have some fun. Do you agree with me that currently blue has a non-function inverse because it fails the horizontal line test? The horizontal line crosses twice. So here is all you need to do to make a quadratic have its inverse be a function. Excuse me. All right, so as I was saying, graph the inverse on the same set of coordinate axes. I already did that. Describe the domain. Done. To get a inverse, who's a function, you must kill half the graph. I'll show you what I mean. Let's assume that I said, oh, no. We're just going to make the domain x is bigger than or equal to -2. There's the quadratic who's -2 and bigger for his domain. Is the inverse going to be a function? And the answer is no. Because take a peek. Look, horizontal line test kills, like, no, that fails. Done. It's over. This inverse is not a function. So going greater than or equal to -2, not good enough. All right, what happens if I came over here and I said, yeah, you know what we'll do? We'll just say that we are less than or equal to 3. Is that good enough? No. So what has to happen here is you must kill minimum half the graph. This answer in D has a multitude of answers. You could argue, one possible answer is to say, oh, x less than or equal to 0. Because think about it. Horizontal line test? Yep, only touches once. That would work. Could you argue, no, I'm actually going to say x greater than or equal to 0. No problem. Go for it. That'll work too. Could you actually kill more than half the graph? Of course you can, because watch this. If I said to you, oh, x greater than or equal to 1, that would work. I've done more than I need to, but it would work. Could I argue, oh, you know something? X is going to be less than or equal to -3. Yep, that'll work. Which means whatever the vertex is, find it. And make sure that you kill at least half the graph. My example is this. Let's assume that I had some sort of cancerous growth in my wrist, okay? Would they get the cancerous growth if they cut off my arm at my elbow? Yeah, that would be enough. Could they cut off my arm at my shoulder? Yeah, more than enough they've taken out. Would they get the cancerous growth if they cut off my fingers? No, that's not enough because it's in my wrist. So the key to this, describe how the domain could be restricted so that the inverse is a function as long as you cut off at least half the graph. So answers down here could have been x greater than or equal to 0, x less than or equal to 0, x greater than or equal to 1, leaving only this, x less than or equal to -2, leaving only up here. As long as you kill half the graph, you are good to go. All right, let's finish this up. They want you to find the inverse at -16. Now, if you want, you could be psycho and go and find the inverse equation, right? X equals y squared minus 5y minus 10. Solve for y, and then put -16 into the function. Go for it. But think about this. This is saying put -16 in for x into the inverse. Well, wouldn't that be the same as putting -16 in for y into the original? So right here, when they're saying put -16 in for x in the inverse, that's no different than putting -16 in for y in the original. My students, we're going to have a nice little quadratic who looks like this. And I know what you're going to say. Okay, no problem. We don't solve quadratics that equal to -16. Move the -16 over, and you'll get 0 is equal to x squared minus 5x plus 6. I think that's going to factor quite nicely as x minus 2, x minus 3, giving me two solutions, 2 and 3. There it is. You got two answers here. So when they give you the inverse at an x value, just make that the y value of the original. Solve it. Same thing. This is the x of the inverse. Oh, no, 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 no. I don't want to look at this. This is x of the original. I'm not even looking at that. This means put negative 16 into y of the original. No. Yes. No. No. I believe that when negative 16 goes in for y of the original, 8 comes out. I am getting the answer for this guy as 8. There you go, my students. That is inverses, and I also believe it is the end of chapter 1. Thank you for your time. Assignments right here. You know where to find me.